This week on Insects for Fun, we're talking about another professional diver. Not the Olympic kind, and not the insect kind either. Let's get into it. The diving bell spider, also known as the water spider, is the only known species to live almost entirely under the water's surface. The species name is Argyroneta aquatica, and this spider is actually the only species from the genus Argyroneta. The modern-day English translation of this would be spinner of silver. The name might be in reference to how the air bubbles it uses look like silver underwater because the actual thread it spins is almost invisible to the naked eye. As for the common name diving bell, this is in reference to one of the oldest devices used to explore the depths of our waters. This device was shaped like a large bell and allowed people to travel deep underwater while still breathing thanks to the trapped air inside. Fun fact, diving bells are still used today and now have multiple varieties with different functions and purposes. Now, unlike real diving bells, the spiders are very small, with the maximum size being around 15 millimeters only, and unlike many other arthropods we talk about, males are actually the larger of the two genders. Females usually cap out at around 13 millimeters, but there is a reason for this. The females have to be smaller because they spend more time and energy making bubbles than males do, and they have to nurture the eggs within the bubble as well. And yes, I'm talking about literal bubbles. The males are also more active hunters and require more strength to maneuver underwater and act against the buoyancy of their bubble butt. You see, these spiders, much like scuba divers, can stay underwater for incredible amounts of time thanks to an air bubble that covers their abdomen. But how do they keep a bubble surrounding their bodies? Diving bell spiders are covered in fine hairs that trap a silvery layer of air known as a plastron. This allows for continuous gas exchange, which means the spider's air bubble is not just a one-time use. It actually functions like a gill, pulling in dissolved oxygen from the water while releasing carbon dioxide. And this isn't the only bubble these spiders use. Both male and female spiders make silken structures in aquatic plants that they use to store air collected from the surface. It starts as a small bubble and expands into a home as the spiders make more and more trips to the surface, collecting fresh air on their abdomen. The diving bell bubbles actually diffuse carbon dioxide and oxygen, much like their mobile lung bubbles, which means as the spiders live and breathe within their homes, the bubble itself adjusts to pull fresh oxygen in from the water. This is also thanks to the silk the spiders use, which allows for the exchange of gases despite being water repellent. Males usually make smaller diving bell homes because they're primarily on the hunt, and as a result don't really nest or upkeep their bubbles, unlike the females who live a more sedentary life. The bubble nests these spiders make aren't simply a rest stop though. They also act as a web to digest food in. The venom these spiders use is far less potent surrounded by water where it can be diluted, and this goes for the inside of aquatic organisms as well, which are constantly filtering water in and out. This means the spiders have to drag prey into their diving bell before they can sedate it and make a meal. Females, on the other hand, tend to stay near their nest and wait patiently inside, sensing vibrations in the water, much like a terrestrial spider detects movements in their web. When an unsuspecting victim swims by, the spider strikes with lightning speed, injecting venom and dragging its meal back to its air chamber. The venom of the diving bell spider is strong enough to subdue prey much larger than itself, paralyzing the victim before digestion begins. As for what they eat, well, it can be anything from small aquatic insects to small fish and even tadpoles. It's also important to note that the bubble nests they make do not last forever. There is a constant small leak of nitrogen gas, which means the bubbles shrink over time. That being said, it is a slow process and may only need more air after a couple days or so. Now let's talk about courtship, because as you might imagine, it's a bit different from your average spider. Male spiders are the ones who have to initiate, which is pretty standard, but to initiate, they either build a small bubble nest near the females and create an air tunnel to enter, or they tap on a female's bubble from the outside, kind of like knocking on a door. If she isn't interested, then she shoos him away in an act of aggression. But if she's down, then the male chases her out of the home and they do a swimming dance around her bubble. This is followed by another tango inside the bubble until they begin mating. Once mating is complete, the females lay an egg sac inside their air chamber, separating it in its own individual room, where it will be safe until the next generation of bubble-dwelling spiders hatches. What's interesting is that because males tend to be larger, there's cases of reverse cannibalism where males will sometimes eat the female spider as opposed to mating. Another thing is that males store their sperm inside their pedipalps. Also, even though smaller male spiders are more active in initiating courtship, the females prefer larger males, despite the potential threat. These spiders can be found in Europe through Siberia and Central Asia, and there's also an isolated population in Japan that's now considered a subspecies. As you might imagine, these spiders cannot live in salt water and thus are found in bodies of fresh water where aquatic plants are plentiful. They can be found in wetlands, slow-moving streams and rivers, ponds, and lakes. Because they're a Palearctic species, their mating season happens in late spring when the weather is warmer and the water is all fully thawed. The spiders are known to live up for 2 years in captivity, but because they are very hard to observe in nature, there are no comments on their longevity in the wild. We do know, though, that the spiders are able to hibernate during the winter months. But how and where? These spiders actually double down on their aquatic lifestyle and go deeper into the water to avoid being frozen by ice. It is in these deeper waters where the spiders build a sturdier diving bell and enter a state of diapause to wait out the colder months. When insects enter diapause, their metabolic functions slow down incredibly, which of course means they don't need as much oxygen and don't produce as much carbon dioxide. They don't even eat. So for a diving bell spider, sleeping underwater in a diving bell is no problem. Now, because male diving bell spiders tend to be bigger, they have been observed to use empty shells from aquatic snails as homes by lining the entrance with silk and then filling the shells with air. This is not only sturdy, but a perfect deception to avoid being predated. But here's the thing, these spiders don't really have that many predators. They usually stay hidden in aquatic plants, and because they don't require as many resources as predatory fish, they can live happily in areas where fish won't go. That being said, they can still get preyed upon by frogs, large aquatic insects like predatory diving beetles, and larger naiads from dragonflies and diving beetles. This is not to say that fish don't eat them, because they do. Fish just aren't the main predator for these spiders. And that is going to conclude today's episode on diving bell spiders. I hope you guys enjoyed it, and as always, thanks for listening. For more episodes and vlogs, you can check out the Patreon. And don't forget to rate this podcast on whatever platform you listen.